Okay. For calculating the sample, the confidence intervals, what you need is your bias, meaning your sample mean, plus or minus critical values times the standard error, and the standard error here is actually the standard deviation divided by the square root of n. Okay, and you remember this guy? We done that before. Here, that one. But okay, let's sink in and then see what we need to do. Okay. Okay, after you do that simulation, what you need to do is the SD and the standard error. Okay. The standard deviation is equal to the STD EVPA of A2 up to T2. A2 up to T2. Ups. A2 up to T2. And standard error is equal to the standard deviation divided by the square root of the sample size. Okay, in this simulation, the sample size is 20, so you got that? Suppose.
Can I see this? The standard deviation.
Okay, standard deviation is equal to the STD EVPA of your data, A2 up to T2. Okay, the standard error is equal to the standard deviation divided by the square root of your sample size. In this case, the sample size is 20 because we have 20 dice. It should be something like this. V2 divided by the square root of 20. Okay. Suppose we need to calculate the 95% confidence intervals. And we will have two numbers actually, 95% lower and 95% upper. But the first step is to find out this guy, the critical values. But how to find it? Okay, so you need to have a Z-score table, and when we need to calculate the 95% confidence intervals, meaning our alpha is equal to 5%, and we need to have the critical values when the alpha equal to 5 divided by 2. So it should be 1 minus 2.5%, so it should be 975. So 1.96. Okay, if you need to remember one number, that number 1.96. So when the alpha equal to 5, it's equal to 1.96. Don't worry, if you are in the exam situation, they will give you this number. You don't need to find that number by yourself, but you need to know how to plug in the number into that equation so that you get the 95% confidence intervals. Okay, the lower part is equal to the sample mean minus the critical values, which is 1.96, times the standard error. Similarly, the upper is equal to the sample mean plus 1.96 times the standard error. Okay, and then you can repeat it for all the other shell. By using the name box and the command D, you should get something like this. And you can look at those 95% confidence intervals. Okay. For example, the first one is 2.51 to 4.09. For that one, it includes 3.5, our population mean. Okay. And that one also 2.41 to 3.89 still included. And the third one, yes. That one, yes. This one, yes. But that one is 1.98 up to 3.32. So actually, it's not including the 3.5. Okay. And if you look at it, most of them will include 3.5. Okay. What does it mean by most of them? Most, what is most? Okay. It's actually meaning 95% of those confidence intervals will include 3.5, your population mean. So in this case, if you really do the counting, you will find that 5,000 times 0.5 equal to 3,250. Okay. 230 approximately, okay, because this is random. Approximately 250 of those confidence intervals will not include 3.5. Okay. That is how our 95% confidence come from. Okay. So when we only have one row of data, meaning we only do one survey, and then we do the calculation of the sample mean and also the 95% confidence intervals, like 2.31 to 4.09. We are 95% confidence that the population mean is actually in that range. Okay, that is how the 95% confidence intervals come from. Okay. Questions? The calculation part is easy, but the theoretical understanding of it may be a little bit trickier. So if there is no question, then we can move on to the task 2. Task 2 is a straightforward packing numbers into formula kind of questions. Okay. The public opinion poll of Hong Kong U or Hong Kong U Pop study the approval rating of the chief executive in Hong Kong every 2 weeks using the random digit dialing telephone survey. The question asked in the telephone survey is, in the general election, if the chief executive were held tomorrow and you have right to vote, will you vote for CY Leung? And we can look at the data by Googling Hong Kong U Pop. Okay, go to their website, and if you have problem reading Chinese, you can use the English version here. And in the tape pop poll, there are 2 different kind of poll done by the Hong Kong U Pop. The first one is the rating of CY Leung. For that one, they use a scale. For example, 0 to 100, and then 0 is not supportive, 100 is absolutely supportive, and then ask the respondent to give a score, and then they calculate the average, like 42.5%. But that is not the one the question is asking. The question is using the second one, hypothetical voting of CY Leung. Okay, and you can look at the table here, and then you get the data. Okay, if there is a general election of CY Leung for voting of chief executive, okay, and you have the right to vote, but actually most of us don't. So this is the hypothetical voting on CY Leung. So it's not actually true because we don't have the right to vote. And we vote for CY Leung, and in every survey they ask this question, and then some of them will say yes, some of them say no, and they do a survey on 1,008 person in the latest survey, and most of them say no. Okay. So in the latest survey, the sample size is 108,008, and there are 60.5 of the respondents said no. Okay, the first question is, what is the margin of error for this survey, assuming 95% confidence? Okay, that one is like this. Okay, what is the margin of error? The margin of error is this guy. P is equal to 0.5. P and one more thing. The standard error. Okay, that one is not a mean. It's not an FA score. Okay, what you get is just a proportion. As you can see, yes, no. Okay, there is no mean here. Okay, there is a proportion. But we can still use this equation to do the calculation of the 95% over the intervals or the margin of error. The bias is equal to the P, meaning the proportion. In that case, is 0.6 something. And the standard error is equal to the square root of P times 1 minus P divided by N is in the lecture notes. But the margin of error in that case, in the question 1 is when P equal to 0.5, what is the margin of error? So we can just plug in the number in this equation and then we will get the answer. Okay. So let's do that together. P is equal to 0.5. And the standard error is equal to the square root of P times 1 minus P divided by the N. The N from the question is 1008. 1008. Okay. You must have problem following what is the formula. So this is the formula. It's actually this one. Square root of P times 1 minus P divided by N. If you type it correctly, it should be 0.15 something. The answer. .157. And then the margin of error is equal to 1.96 times the standard error, which should be 3%. It actually should be something you know without doing any calculation, because in the lecture slides there is a graph like this. When the sample size is about 1,000, the margin of error is 3%. It's roughly 3%. So, because the sample size is 1,000 something, 1,008, so it should be very close to 3%. And you can read this graph. You can also get the answer. Most of the survey is in this range. The sample size of most of the survey is 1,000, because this is the best sample size if you need to further reduce the margin of error by 1%, you need to add 1,500 more sample size. If you further need to reduce it by 1%, it will be 5 times the sample size of 1,000, which is not economical because you need to have people to do the survey, right? So you increase the human resources by 5 times, but your margin of error only reduce it by 2%, which is not good. So most of the survey will choose a sample size of this number, actually. So that is your answer, 3.1%. This is the first one. Okay, the second question is, what is the 95% confidence intervals of 60.5%? Okay, that one is even easier. You just you just change it, that p to 0.603 because 60.5%. Okay, and we have the margin of error already, so we can calculate the 95% lower and the 95% upper, which is equal to the p minus the margin of error and also the p plus the margin of error, and we have a range 57 to 63. Okay, we are 95% confidence that 57 to 63% of the Hong Kong population will not vote for CY Leung. It's actually meaning that more than half of the people in Hong Kong dislike CY Leung. That one still is easy. Okay. The next one, question 3, is difficult and easy at the same time. Okay. What we need to do is to extract all the information from this year, all the survey from this year, and then calculate the 95% confidence intervals for all of them. In the previous one, in the previous tutorial, previous section of the tutorial, this question is difficult. But for now, this question becomes easier because I have done the data cleaning part for you. And there is a link to the Google Drive data, and I have already cleaned the data for you. So you can just download it as XLSX or CS3. Okay, let's download it as XLSX and then open it. So now you have the sample size and also the proportion of the respondents saying no in a nicely formatted way. So now we need to calculate the 95% confidence intervals for all of these surveys. So we can just plug in the number into the Excel formula. Okay, zoom in. Lower and 95% upper. So SE is equal to the square root of P times 1 minus P divided by the n. Should be something like this. I want to show you the equation again, which is something like this: square root of p times 1 minus p divided by n. Okay, and the lower bound is equal to the p minus 1.96 times the SE. Similarly, for that one should be the P plus 1.96 times that one. And then we can use the lane box D2 up to F23, and then Control D, do all the calculation. And then you have things like that. You have all the confidence intervals for each survey. Okay, the question wants you to plot a line graph on the confidence intervals. So what I did is copy and paste the low, meaning the C column, to the G column. Select the E2 up to G23, and then plot a line graph. Okay, it should be something like this. The green line is the P, and the line, the blue line and the red line is the confidence intervals. Okay. And it will be much nicer if you change the x-axis label to the date. Okay, it should be something like this. If you turn in something like this, I will give you marks. So the next one is that where's the question? Okay, here. Comment on when did the approval rating of CY Learn change significantly recently, and what happened during that week. Okay. What is a significant change? Okay. A significant change meaning that in two successive surveys, their confidence interval do not cross each other. Okay. For example, that one, they cross each other. What is the meaning of crossing each other? Okay. This is a number line. one dimension. So the first one is up to 63.3%, and the second one is 56.3 up to 62.3. As you can see, there is some overlap here, right? So if there is overlap, we cannot say this one is a significant increase or decrease. What is actually a significant change is that two successive confident intervals didn't cross each other. Okay, and if you look at the data, there should be some occasion that for example, this one, no, they still cross each other. Yeah. It is possible that actually the approval weighting of CY learn hasn't changed. Actually, the approval weighting of CY learn hasn't changed much. Statistically speaking. But for example, that one, that two, I mean this week to this week, to this week, okay, meaning 14 and 18. As you can see, that one is 55% to 61.6. And then that one is 61.2 up to 67.2. Actually meaning that the confidence intervals somehow not cross each other. Plot it out. This one is 612 and 672. And the older one is that one. They just overlap. They didn't cross each other. There is no overlap. So you can say that, okay, there is a change. And you can go home and find out what is happening during that week, that period of time, which making the CY learn approval rating better. Lower meaning better, right? So what make it improve? And if you look further, for example, if we compare the rating in late April to September, okay, late April to September, the CY Learn rating actually increased by 6 units, 6%. And then when you look at the confidence intervals, that one is 5-2 line to 5-8 line. And then that one become 5-1. As you can see, these two numbers didn't cross each other. And up to 6-5-1. So CY Learn rating from April to September become worse. Okay, there must be something happening during this period of time, and I can drop you some hints. Actually, the political reform package is somehow in that period of time. And also that one is the anniversary of the September 28th. So still people will remember what CY Learn did last year, so it's still at the poor level. And then people start to die off. Okay, the take-home message is that when there is a change in the rating from survey, you need to calculate the 95% confidence intervals so that you can comment whether that change, the change in the approval rating of CY Learn is statistically significant. If that change is like less than 3%, you cannot say that that change is significant. It's just a sampling error. So finally, is state all the assumption and condition on how and why the result from the survey can be used to infer the overall approval rating of CY Learn. It's just assumption of the central limit theorem. The assumption of the central limit theorem saying that your sample need to be a representative sample. Representative sample meaning random sample, actually. Okay. Everyone has the equal chance of being selected. And secondly, your sample size need to be large enough. If the sample size is large, the sampling distribution become normal, so that you can use the normal assumption to calculate the 95% confidence intervals. And secondly, because your sample size increase, so that your estimation become more precise. You can get a more accurate estimation. And that's it. Next week, there is an optional class, optional tutorial. You have the right to attend it or not. There will be a 2-hour tutorial from 9:30 to 11:30, and once again, it is not an official tutorial. It's like an optional. So we will do a revision on the exam questions. We'll do some exam questions together so that you can be prepared for the exam. And so if you have time, you can attend it. If you don't need to. Yeah. So if you have no question, you can go now. So yeah, that's it.